problem that we want to start with is called the Caesar's cipher. The problem is simple. Caesar wants to send a message to his general hundreds of kilometers away, right? So we have Caesar and you have his general here. They're separated physically, and he must use a messenger on a horseback to deliver his handwritten note to the general. And Caesar does not want the messenger to be able to read the message and potentially leak the message. So what can Caesar do? So here's what he does. So Caesar sends the message IFMMP. This is what he writes on a piece of paper, gives it to the messenger, and asks the messenger to deliver it to his general. So even if the messenger reads this, he doesn't really get to know much information. It's pretty much gibberish. But the general knows a secret. When the general and Caesar met in private, so let's say they had a private dinner somewhere, Caesar told the general a secret. He told the general how he's going to be sending messages. So basically what he's going to do is he's going to shift all the letters by one. That is, if he wants to write A, he'll actually write B. If he wants to write B, he's actually going to write C, and so on. So Z word map to A. So when the general receives this message, all that he needs to do is unshift every letter by one. So B becomes A, C becomes B, and A becomes Z. Right? So let's just look at our message. The general would have to look up what is the letter just before I. It's H. What's just before F? It's E. And HELLO. So it says hello. So Caesar says hello. So the general has been able to successfully decipher what has been written on this paper. But let's relook at this from a technical lens. Right? So when general and Caesar met in private over here, they discussed two things. First, Caesar told the general how he's going to morph the message. That is, he told the general that he's going to be shifting each letter in the message. Right? Each letter in the message is going to be shifted by a certain amount, and that's the algorithm that he's using. The algorithm used to morph the message is called a cipher. And secondly, Caesar also told the general a secret number. In our example, that secret number was 1. That is, how many positions is each letter shifted by? Is it shifted by 1, 2, 3, and so on? If all that the general knew was that the letters were shifted, but did not know that they're shifted by 1, the general would not be able to come from this message to hello. So knowing that the secret number k is equals to 1 is just as important as knowing that the algorithm that was being used to encrypt the message. If the general does not know the number 1, the secret number 1, they might have to just try every possible number and try to see if any of them make sense. If they do, that is probably the number. So they'll probably have to try all the numbers from 1 to 26. The fact that Caesar and the general were face to face over here at their private dinner when exchanging these secrets implies that they had a secure channel of communication. Right? So when you're face to face, only two people probably in the room, nobody else overhearing you, it's probably safe to call that a secure channel of communication. Right? No secrets are being leaked. The information is being successfully passed from Caesar to general. So this is what is called the setup of an encryption. A similar setup was used by the Nazis, albeit a more sophisticated one, in World War II. And that encryption was broken by the famous Enigma machine that Alan Turing built. Unlike the general, Turing did not know the shared secret, so he had to try all the possible values before the time runs out. There was a specific time constraint that the communication between the Nazis involved, and that's what his computer did. It managed to try out all the possible values for the secret number before the time ran out, and having a computer instead of humans doing it definitely came in handy. Anyway, for the cipher to work, you need a shared secret, right? So this shared secret is super important. If you're Caesar and a general who met in real life, you could share this secret over dinner. But what if there is no way to meet, right? Maybe you could, in modern times, you could probably call up the other person and tell them a secret. Hey, k is equals to 1. But someone could be tapping your phone, right? That is real. Then how do you set up a secure channel of communication with somebody that you met over the internet and at scale? right? So on the internet, you're usually talking to thousands of people directly or indirectly. So how do you set up these secure channels of communication over the internet, especially when you can't meet in person, right? So the shared secret also needs to be communicated over channels that are susceptible to being read by an adversary. What that means is, even if I'm going to be calling you up and telling you this shared secret, somebody else could be tapping my phone and getting access to this shared secret. And the next time that I'm sending you encrypted messages, the adversary also has the shared secret and they could decrypt the message as well. It's not only going to be you who can decrypt this message. So in the next video, we're going to be looking at how to implement something like this, but without meeting in person and without setting up a shared secret beforehand. Okay? That's for the next video. I will see you there. Thank you.